Today we're going to revisit area and determine how to find the area between two curves on a graph. So the first thing we want to make sure that we do is we remember that the area between a function and the x-axis is just denoted by the definite integral. But when we're finding the area between two curves, if we've got a graph, we always want to read the graph from top to bottom. So we want to integrate the area under the larger function and then subtract off the area under the smaller function, and it's going to give us the area between the two curves. Some functions may crisscross along the way. So a function that's bigger in one section of the graph may go below it in another section. So you can kind of see this if you ever graph a cosine wave on top of a sine wave. You can see that they're constantly changing places. So one of the things we have to verify is there any points of intersection on the graph, and they might trade off as top and bottom functions. So if you can visually see that on the graph, you can just split the integral by looking at the graph itself. If we do not have a visual of the graph, we can find the points of intersection and break the regions up into intervals. And then by testing y values on each function, we can see which function is bigger than the other in each chunk. Once we're done, we would add up the totals of the individual integrals to get the total area. When f is above the x-axis, it would be the top function. So let's just say we have a function on its own and we want to get the total area. Well, we saw in a previous section that total area, right, is the positive areas minus the negative areas, and then those negative areas will get added back in. But if you have a function that is above the x-axis, right, then we would just integrate f of x minus 0. So we would treat y equals 0 as the x-axis and as our second function. If it's below the x-axis, then we would take 0 and subtract f of x, and when you integrate negative f of x, it's going to give you the positive area on the function. So if you get a negative area for any of your integrals, we need to stop and reevaluate the setup and make sure that the area should be non-negative.